Okay, go to a website that'll let you download that for a temporary version for 30 days or something like that, if you really want to study that. But I mean, you spent 3 days in the lab doing the same SOS, right? So, oh, wait a minute, let me turn it off, then you can say. This diagram is pretty familiar, Kritik? Seen there, been there, done that many times? Okay, one more time. In the lab, we used to call this
delta y.
Delta y, Henry. And in the lab, we used to call that H. Okay? So notice that as x goes towards c, x minus c, which is equal to h, goes towards 0. Right? If x is going towards c, x minus c is going to go towards 0, because it's going to be like c minus c. Okay? Well, this is not very different from what we had earlier, right? Lim h goes to 0 of fx plus h minus fx over h. Right? Kind of very similar, except what we are doing is we are finding the derivative at one point only. In other words, we are trying to find the slope of that tangent line. All right, you guys with me on that? All right, so if you go back to 2.1, what this is saying is that we need these two limits to exist and be equal. Okay? Which then implies that a function is continuous. And I know right now this is all kind of sounding abstract, but we're going to see some diagrams and I'll explain that to you. What I'm trying to do is explain the concept of differentiability. In other words, can the function be differentiated? Can you find a derivative of a function at every point? Okay, that's the concept I'm trying to get across today. Yeah, those are the one-sided limits, remember? The c minus is the limit from left and c plus limit from the right. Okay? So you've seen these things before. Okay, you guys with me on this? Okay? All right, so here's the definition of, you guys ready?
No.
Well, then I'll be stuck here if you say no.
Yes.
Oh, Cindy. So what are we going to do? You want me to do only 2 chapters in the entire year?
That would be really nice, actually. As long as we understand.
Oh, you're going to do only 5, so through the entire year. Okay, so function is differentiable, then f is continuous. Okay, so in other words, if you can differentiate a function, then it's continuous. So that's number 1 in the notes there. Okay, number 2 in the notes tells you doesn't have to work the other way, and I'll explain that to you in a minute. Okay, so in other words, if you can differentiate a function, it's continuous. However, if it is continuous, no guarantees that you'll be able to differentiate that. No guarantees that you'll be able to differentiate that. Again, everybody understand the word differentiability, right? Yeah, does someone want to explain to me in simple language what that means? Carme? Don't want to explain, or you don't know? Anybody? Eric? You're smiling. You got it. You didn't get it? Differentiability, someone want to explain? Ine? Hello. Thank you. Sujal, when convenient. Sujal, do you want to explain what differentiability means? I thought you guys told me you got it. Chris? Monica? I'm just going to pop a vein here pretty soon, okay, if I don't get an answer. Yeah, Henry.
There's a point there. Is it tangent? Tangent? Something about tangent.
How about something about derivative?
Yeah, it's like derivative.
Yeah, differentiability means you can find the derivative at any point on the graph. Okay, you guys want to write that down? Okay, differentiability equals there exists a derivative at every point on the graph. Differentiability. So the first note is saying that if a derivative exists at every point on the graph, then the graph is continuous. Okay? However, if it is continuous, it's not necessarily differentiable. Not necessarily differentiable. Okay? And I'll give you two examples. Here's one of them. If you were to graph this, what would this look like? It'd be a V. Is everybody with me on that? Those are straight lines. Okay? If I take a look at a point here on the graph, what do you think the slope of the tangent is at that point? You just did. Remember that exercise that you just did? 2x minus 3? Right? What was the slope of that line? Right? It was the slope of the line. In other words, the derivative was the slope of the line. So what's the derivative at this point? Sorry? What is it? Negative 1. What is it here? Here. And when it's really close to the tip here, negative 1. How about on the other side? Good. So you got that? That's plus 1, plus 1, plus 1. And when you get very close, plus 1. At this point here, where you go? Well, this is the touch screen, so if I touch it in the wrong place, it goes ballistic. Okay, so at this point here, right at the tip, on the one side it's minus 1, on the other side it is plus 1. Doesn't know what the derivative is. Am I a minus 1 or am I a plus 1? I have no idea. I have no clue. So then this is this function continuous, first of all? Why is it continuous? You can draw it without lifting your pen. Okay? But it is not differentiable because I don't know what the derivative at that point is. Is it a minus 1 or is it a plus 1? I have no clue. So this is not differentiable. Okay? It is continuous, but it is not differentiable. Okay? That's one example. Right? I'll show you another example. Is this a continuous function? No? Did I not draw it without lifting my pen? It is continuous. Can I draw a tangent at this point? Does it have a slope? Yes? How about here? How about here? Does it have a slope? Undefined. It's vertical. Okay, so if you have a vertical tangent, not differentiable. Is it continuous? Yes. I'm done. That's it.